What? Hey guys, try these problems right here. All you're gonna do here, guys, is you want these first two. You want to rewrite these first two so they look like 3 and 4, and then you want to write 3 and 4 like 1 and 2. That's all we're doing. Easy peasy. Lemon. You know what? That's enough out of you. You can move my.
Oh, I'll move your stuff.
Wait, does it matter?
I like to move it.
Madagascar. I like to move it.
No.
See what? Are you mumbling something you heard in church?
Have you guys
You're
not
speaking
heard
in
of
tongues?
Have you guys not heard of that?
Is it coming fit?
It's me. What?
Is it coming fit?
That's not what it sounded like what she was saying.
I don't know if that's what she was saying.
You doing Madagascar?
Yes.
Yeah, it's hilarious. I love the Penguins. Oh my gosh. Skipper, Private,
I think we should watch
Kowalski.
Madagascar.
When they're trying to fly the plane,
Yes.
nothing seems to be responding. Skipper. Funny, man. Did you ever see the Christmas caper? I showed you that, didn't I? Madagascar penguins. It's like 10 minutes.
Maybe.
Oh my gosh.
Watch it again.
It's. I can watch it 10 times.
That's all fine.
You. Jealous enough out of you. That's enough. Yeah. I couldn't even walk out. Well, I could have. I couldn't even walk out my side door to get to my garage.
There's a foot of Amazon man.
Unreal.
In the snow. I literally opened the door and was just like,
Poor Wheezy. I had to shovel a spot so Weezy could even go outside.
my dog walked out of the back deck and just I was like, well,
My cats are indoor cats now, apparently.
I would be too.
I like to move it. Okay, guys. What's this called number again called? The fourth root. What number starts with the I? You remember? Indica. Index. Okay. So how do I want to write this? What power is 51? To the what?
1/4.
Yeah, it's to the first. Okay, so I'm going to write, whoa, sister. I'm going to write 51, and the power goes on top, and the index or the root we're getting goes down there. So that's 51 to the 1/4 power. So what would 2 be? Or not to be?
That is a question.
Is it appropriate?
Yeah.
Okay.
We missed a lot, but who knew today's?
I think we should every single
Nope.
Okay?
Best present this year was a broken drum. Can't beat that.
That's ridiculous.
Guys,
I'm not
Wait,
even
that
going to
wasn't
smile.
today's. Hold on. Today's not Monday. Broken guitar for sale. No strings attached.
Hey, Dorian, sneeze, dude.
No.
That's terrible.
I'm not even smiling.
There's a big sale on rowing paddles at my local shop.
Wait, there's a big what?
A big sale on rowing paddles at my local shop. It's quite an ordeal.
Stop. Just stop. All right. How do I write this? Brandon, go ahead.
8/5.
Well, no. It's 8 to what power?
5.
The cube, the root, what we're getting goes down in the denominator. The power goes on top. So it's 8 to the 3/5 power. Power. Now, let's reverse it, my brothers and sisters. You stop drinking before math class. All right? I know it.
Oh, I
I
did
just
that one backwards.
can't.
Wait, hold on.
Why not?
It's the grapefruit oranges. They get me in.
They must have fermented. All right. But years ago, this one before I came around, my mother, they used to have like quilting. Well, that was a big thing in the Amish to make there. And then like homemade grape juice. It fermented. Let's just say they were a little.
I saw a meme.
All right. How do I write this? Somebody help me out. What is this going to be?
Like the third,
Third root
yeah. And then
of what?
8.
8 to the.
Fourth power.
Now, you can write it like that. Does anybody else remember how else we could write it? Go ahead.
8 4 well, in a little. Oh, never mind.
No, you want to do this then.
Oh yeah.
Either one of those is right. Yes? Okay.
Never mind.
Yeah. Jonathan's going, what the? Jonathan, this is math. We've progressed a long way.
I get it.
Have you been watching stuff online?
Yeah.
Good. All right. Luca. He isn't even laughing before I even asked you a question, Luca. Luca, I didn't see you upstairs today. Were you up there?
Upstairs where?
On the. This is the first floor. What?
This is
First.
No, it's ground floor.
No, third.
Still first
I
floor.
think it's the fourth.
First and a half.
Second floor.
We didn't see you in the second floor. Actually, did I?
Don't you live there? Luca, what do you? How many? What do you call those things? Energy drinks did you get that day? Hey, Luca, what do you think about this one? What do I write in the root in the index here? Huh? Good. 17 to the third, or it could be like this, guys. The 5th through to 17, all raised to the third power. Both those are right. Yes.
Class.
Ceasing. Okay. What is this one going to be? Write this in exponent form. This would be, guys, remember, if there is no index written, what is it? What's the index, Liv? 2. So what would this be, Liv, in exponent form? Oh, my. Come on, air 5. Nice job. 10 to the 1/2 power. Okay. 3, we want to switch it. What does this look like? Samara, what would this look like, number 3? What root are we asking? Good, the third one. So what are we writing here? Do you write 1 if it's to the first power? No, don't write it. Don't write it. Whoa, son of a nutcracker sweet. Okay, this is asking for what? The square root of, and same thing, guys, if it's square, the square root, you don't have to write the 2 there. It's not wrong, but you don't have to write it. What's the square root of 36? You still agree your argument's not negative still? It's just 6. Square root of 36. Just 6? Okay. So if you wrote 6, that's the answer. Okay, what's the cube root? Vince, what's the cube root of 1,000? No, we're on 7. For number 7? Because you said 10. Vince, I'm
He's just playing.
just messing with you, man. It's 10.
Yes, and no one told him.
It's 10. All right, yeah, that's it. Okay, we had to figure these out, right? Okay, guys, you had to put, is everybody okay finding the fourth root or whatever root besides 2 in your calculator? Evan, what's the fourth root of 256? Whoa! No. Because I know 64 times itself 4 times is going to be way bigger than 256. Somebody help me out. Yeah, what'd you get?
4.
It is 4. Did you know how to find the fourth root on your calculator?
Yeah.
Well, get your calculator out and try it again. Make sure you get this. If you don't, raise your hand. No, it's just 4. Just 4. Now, I know the cube root. Are you okay? You got it? Okay. I know this is going to be negative, Joe. What'd you get? What's the cube root of negative 343?
-7.
Now, what is this asking here? 28 to the 1/7 power. You can put that in your calculator. Just remember, guys, if you do that, when you hit your caret button, make sure you go like that. Make sure you put it in parentheses. It's asking for the 7th root, isn't it, of 128? You could do that in your calculator too. Is it 2? Okay, we're doing rational exponent form. Samara, what would you get for 17 exponent form? 8 to the what? What happened to the 4? Huh? Smart. Get out. Smart. It's ask. The root it's asking for goes on the bottom. The power goes on top. So it's 8 to the 4/5 power. Radical form. What'd you get this one? Where'd you get this one, Dorian? Huh?
I'll have it down.
Huh? What's the index? What goes?
7.
So it's the 7th root of what? -4 to the 2nd power. We had to evaluate these. 21. What'd you guys get there? What'd you get? I think that's right. I think it's 8. Does anybody need me to work that out? Because think of it like this, guys. The 5th. Here's how I would do this problem. I would do it like this, and then I'd cube, because this is going to be a big number. Everybody take your calculators right now. Excuse me. Everybody take your calculators now. Get the 5th root of 32. Make sure you can get that. It should be 2. Make sure you can get that on your calculator. You want to show him how to get that on the calculator if he doesn't know, which it's. Did everybody get 2? Okay. So guys, I'm left with this. 2 cubed, 2 to the 3rd power. There's my answer right there. Is everybody okay? Yeah? All right, was that it? Okay, put those away.
Do we have to do it like that, or do you want to do it the 32 parentheses?
You could do that. You could do 32 caret parentheses 3 divided by 5 parentheses. Same thing. Guys, pass those over to Corbin, please.
There's a mouse sword. There's a mouse sword. How do you get that? Oh, yeah. I didn't get paid anything.
You haven't?
No.
See, Mr. Westphal.
Speaking of getting paid, I'm spending my whole day getting paid. I should get.
Again, you're going at once.
Because I wasn't treat it like a job, so like the first
So you're gonna get money.
What do you mean? Your money for work?
yeah,
For school?
This is a
Your money for coming to school? You're
This
getting.
is a privilege.
Gosh almighty, this is like
There's some
talking
people
to.
that cannot do this.
I know.
This isn't-
No, we are. You're getting paid with knowledge.
Yeah, exactly. I don't.
Knowledge is not made.
Oh, yeah, no, knowledge is going to get you a job when you graduate. What do you mean, no, it's not?
This is like the like six.
Guys, we're going to talk about exponential functions today. Okay? Writing them and graphing them, okay? Okay, you guys have this on your.
Yes.
Okay. Now, let me see, I think. All right. Exponential functions right here. All right. If they kind of look, and by the way, they can open up or down, but they'll never hit, even though they look like it, they'll never hit the x-axis. Okay? Now, do you guys remember a linear function? We'll talk about the difference between this and an exponential function here in a second. Okay, so basically we started, guys. Here's my x and y. Make a little table like this. Go make it down. Okay, so after a second, it doubled. Okay, we got 4, and that's graphed. After 2 seconds, it doubled again. There were 8. After 3 seconds, it's graphed, and there were 16. How many would there be after 4 seconds? It's on the graph, but look here. It'd probably be easier to see it. How many after 4 seconds? Aaliyah? No.
Oh, one.
No. What's happening each time to the y's?
Go.
They're doubling. Right?
Yeah.
So what would 16?
Wait.
What?
Oh, wait.
What would 16 doubled be?
31.
Nope. 32, guys. How do you double something, guys? Multiply it by what? Thank you. So after 5 seconds, how many would it be? How many? 6 seconds. 6 seconds would be 128. This is an example of an exponential function. And you can see it right over here. Do you guys have this? You guys need to graph 3, 4, 5, and 6 here. And it should be like this then. After you should draw it. It goes up pretty quick once it starts going up, and you should have an arrow on both sides. Finish graphing it. This is the function that we just graphed. Okay? This is what we started with. We started with 2. And then this would be doubling. I'll show you how we get that number here in a second, to the x power. That's what an exponential function looks like. So I want to show you this. Now, where is that at? Yeah, right here. This is, you guys have that. So it's really a f of x or y equals a times b to the x power. A and b have to have numbers for it to be an exponential equation. A and b have to have numbers. Now, look what's going on here. And do you guys have this, right? Somewhere or no? Do you have this? Do you have this graph?
No.
Okay, so what's going on here, guys? How do I go from 2 to 6? I multiply by 6 times 3 is 18 times 3 is. Okay, so we're multiplying by 3. That's so A. What am I starting with? That's what A is. What am I starting with? 2. So this would be f of x. A is 2 times what would be 3 times 3. Kind of do that. You put it in parentheses. Then what am I going to write here for the power? X. Just write x. Just write x. Because that's what these are going to be over here. Okay? So let's determine if it's exponential or not. Okay, be careful. Look at the first one there, A. Is that exponential or not? I'm going to say it is exponential. I'm going to say it's not. I agree it's not. Why isn't it? Go ahead.
Because there's no parentheses around x.
What does B have to be? This is B, right? What does it have to be? Has to be a number. And remember, the exponent will always be x. So this is no, not exponential. No, not exponential. How about B? Is B exponential? Zach, what do you think?
Yeah.
Yeah, I have A's a number, B's a number, my exponent's x. Yes. Yes, exponential. How about C? Yes. Be careful with D. Let me see. B has to be what, guys? A can't be 0. B can't equal 1, and B has to be greater than what?
0.
Okay. What is B? What is B right here? It's less than 0. So that's why that is not exponential. So no. Not exponential.
Is it okay if A is a negative number?
Yes. Okay, here's what we're going to do now. Do you guys remember when we worked with linear functions? Remember linear functions just a line, right? What was there? There was a common constant what? When I change, so what's that mean? Constant, when I subtract numbers, what's that called? Somebody said it. Starts with a D. Constant difference. That's linear. So we're going to have to determine here in a second, is it linear or is it exponential? Exponential they do not have constant difference, but they have a common ratio. And we'll look at that right now. What's that mean, a common ratio? Okay, look at this table here, guys. Okay, it is a exponential. Did you say function? Okay, here's what I'm saying. How do I know it's not linear? Guys, what's 12 minus 4? Now, if it was linear, it would have a common difference, right? So 12 minus 4 is 8. What's 36 minus 12? Okay, it's not linear. Okay, it's not linear. And these are going up by the same too, by the way. Okay, so here's what we do. It's gonna have a common ratio. What's 12 divided by 4, guys? Does everybody agree it's 3? Okay, slide it down here. What's 36 divided by 12? There's your common ratio. What do you think 108 divided by 36 is? 3. And there's a common ratio, therefore it's exponential. I'm gonna fire away, fella. You want to do this one? You take over?
Sure.
You want to go? All right. Okay, let's determine, guys, if it's linear or exponential. Okay. Now, these have to go up by the same, and they do. We're dealing with the y values, right? Okay, what's 4 minus 2? Okay, let's see. Is it linear? What's 4 minus 2, guys?
2.
What's 6 minus 4? 6 minus 4.
2.
I know we've been off school. It's okay. Yeah, it's okay. And then 8 minus 6 is what?
2.
Okay, is there a common difference?
Yes.
So this is what? If I would graph these, it would be a line. So this is linear. Because there's a common difference. You guys have that graph?
Thank you, sir. All right. Do you guys remember doing the quizzes and tests where we decided if they were linear or not linear? Yeah. So it wasn't just the y's. We had to look at the x's too. They're going up by 1 each time? Awesome. What's the check for differences first? What's the difference from 4 to 8? 4. 8 to 16. 8. 16 to 32. So not linear. Do you agree? And for visual people, linear goes like this. You go over a certain amount, you go up a certain amount. You go over a certain amount, you go up the same amount, right? It's linear. Isn't an exponential function pulling away? It's growing faster than that, right? So it's not linear, but that doesn't mean it's exponential. It might be something else. Let's check. What's 8 divided by 4? 2. What's 16 divided by 8? 2. What's 32 divided by 16? 2. Very good. So we would say this one is
Exponential.
if you had to explain it, you'd have to say that the common ratio is 2. Common ratio is 2. Make sense? All right, evaluate each function for the given value of x. So when x is 5, we have to plug 5 in. So we have y equals 4. What operation is happening between the 4 and the... Yeah, it's 4 times 3 to the x. And 3 to the x, for this case, x is 5. In your calculators, what operation should you do first?
Parentheses.
Yeah, 3 to the 5th, and then multiply that times 4. So 324. 972.
Yeah.
When x is 5, y is 972. You're going to need some big graph paper for that one. All right, try this one. When x is 12.
That's a lot. Round 200 seconds.
Let's do hundreds. 2 decimal places. Everybody know how to enter this one in? All right. Vince, what'd you get? I thought, did you type it in?
No.
Who typed it in? Corbin, what'd you get? Zach.
2,910 and 3,800.
That's what I got. 2,910.38 or 38. Everybody getting that?
Yeah.
All right. Have you heard of the word asymptote before?
Sounds like a strange disease.
Yeah, don't abbreviate it, okay? An asymptote is a line that a graph approaches more and more closely. The x-axis is an asymptote of the graph of y equals a times b to the x, okay? I wasn't planning on doing this, but a quick little example. Braden, help me out. Stand up. See the door?
Yeah.
Go halfway there. Stop. See the door? See your distance? Go halfway. Good. You see your distance?
Yeah.
Go halfway. Go halfway. Go halfway. Go halfway. Is he ever going to hit the door?
Yeah.
No.
If you keep going halfway, you'll never hit the door. Did you know that?
Oh, I see.
If you keep going halfway, the amount you have left, half of that.
Time.
Amount you have left, half of that. Is he approaching the door? But is he ever going to hit the door?
No.
That's what an asymptote is. See this asymptote right here? See this graph? Just look at the blue graph. These are separate, red and blue. One's coming from the bottom, one's coming from the top. See the blue graph? That's exactly what he just did. His distance, thank you. His distance is the y value. His distance is the y value. Maybe he had 16 feet. Maybe he had 8 feet. Maybe he had 4 feet. Maybe he had 2 feet. 1 foot, a half of a foot, a fourth of a foot. Do you see what I'm doing? See what I'm doing? He's going halfway there. That x-axis is the door. He keeps getting closer and closer. He's never going to touch it. Do you understand that? That's a weird attribute of exponential functions. Okay? All right. Make a table of values, plot the ordered pairs, draw a smooth curve through the points. All right. So here's what we're going to do. We're going to do the x value here is going to get plugged in to here. All right. Then we're going to multiply it by 0.5. The answer we're going to put into this y value right here, and then we're going to graph it. Everybody with me? Let's do it. We have to do this quickly. So 2 to the negative 2 times 0.5. I'm getting 0.125. 0.125. Do you guys all agree with that? If you don't, ask for help. 2 to the negative 2 power. All right, so if this, let's graph this one together. So all eyes up here for just a second. When x is negative 2, the y value is 0.125. That's a small decimal, close to 0, but positive, right? Let's plug in negative 1. 2 to the negative 1 power times 0.5 is 0.25. 0.25. That's a fourth, right? So here is -1. I am at a fourth. When x is 0, actually, I don't need to put this into my calculator. What's 2 to the 0 power? 1. Remember that from last week? 2 to the 0 power is 1. What's 1 times a half? A half. So a half, 0.5. So when x is 0, y is 1/2. You know what I'm doing that's weird right now that I don't like? I apologize. I didn't make this graph, so I'm making an excuse right now. Okay. Whoever made the graph, I think, is calling these 1 unit and then calling these 1 unit. That's kind of weird. So I'm using the boxes. Do you see what I'm doing?
Yeah.
So this is 1 unit here. It's okay. It's not to scale. On the y-axis, that's 1 unit, but on the x-axis, I use those big dashes as 1 unit. Are you guys okay with that?
Yeah.
Sorry about that. All right. When x is 1, what's 2 to the first power? 2 to the first power. 2 times 1/2? 1. So 1, 1. And then when I plug in 2 to the second power is 2 times 2, 4, times a half, 2. So this graph would actually look like this if I kept it going. And you don't quite know that yet, and that's okay. We'd have to keep plugging in values. But this is a smooth curve that grows exponentially. Do you know of any things in our lives that grow exponentially?
My bank account.
Ooh, making it rain. I wish. Actually, it depends on how you
Plants.
compounding interest. What?
Grow
I didn't hear what you said. What does? Plants?
Kind
Have you guys heard of radioactive decay or bacteria growth?
Oh yeah.
That grows exponentially. Radioactive decay decays exponentially. You can never get rid of it. It just gets closer and closer to 0 in amount. The pandemic, if you were to look at parts of the growth curves, when you spread a virus, it's getting real here, but when you spread a virus, watch what happens. Listen, see if you can hear the common ratio. If I spread it to 2 people, and then they spread it to 2 people, and then do you see how that grows exponentially? Ready? 1, 2, 4. Can you hear it?
6.
Nope. Those 4 spread it to 2 people each. 8. Do you hear it? That's exponential growth. Until, see now that, we'll talk about that later, but if it keeps growing exponentially, it's impossible because the world population will be hit too soon. There's other factors in play. It actually will start to taper off. You might even say you flatten the curve.
Voila. The homework?
La tarea.
That's right. Yeah, no big reason. That's what I thought.
You're welcome.
Right, it's terrible.
You probably want some graph paper.
What's happening?
At times, stocks can grow exponentially. Again, just like real life scenarios,
That means we have 10.5.
there will be real life scenarios that will